Marc Fleurbaey, presenting on the green liberal dilemma in climate policy. A couple months ago, before the start of the semester, Terry found an earlier version of this talk that Marc did, and he sent it around to a bunch of us. And I offered to say, well, I think this is perfect for a seminar. I'll ask Marc whether he'd be willing at short notice, come in this semester and give us a talk. And Marc kindly agreed to do that. Just so you know something about Marc's background, he's the Robert E. Kuenne Professor in Economics and Humanistic Studies at the Princeton University Center for Human Values. His research centers around theories of distributive justice and social choice theory, with special interest in application to climate policy, redistribution, taxation, and equality of opportunity. And this last bit is the focus of this talk, which we're all looking forward to. Dr. Fleurbaey is the coordinating editor of Social Choice and Welfare, and he's the author of over 130 articles and 18 books. One of my articles that I've known Marc's work for a while about is a Journal of Economic Literature article in 2009 called Beyond GDP. And I still consider that one of my favorite JEL articles and one of the best introductions to that topic. And indeed, among his books, Marc has actually produced a book called Beyond GDP with Didier Blanchet, which expands on that 2009 article. He's also included books, among his books is Fairness and Responsibility in Welfare and A Theory of Fairness and Social Welfare with Francois Monaquet. So Marc, it's a great pleasure to have you. Thank you, and I look forward to hearing your talk.
Yeah, thank you very much, Ed, for the kind introduction, and Terry as well for arranging all of that. I should specify, as you may see on the first slide, I have moved actually back to France. So I'm now at the Paris School of Economics. I decided to do that before retiring so that I could reduce my traveling because my ecological debt was really impossible to bear. And so let me start. Yes, indeed. So this is a talk that is about the difficulty of combining environmental and social priorities, even though in a way it looks like the correlation is obvious. People talk about that a lot in the Green New Deal discourse that you have in the US and that we have in Europe. The Sustainable Development Goals are all about that. And when you look at the political landscape, you see the correlation in people's values as well. The people who have a strong environmental concern are very often people who also have a strong social concern. Just a few illustrations about this for the US. So this comes from the World Values Survey. And you see the support people give to economic growth, that's the red curve, and protecting the environment, that's the blue curve, depending on how they support, how much they support the idea that incomes should be more equal, or that inequalities are okay in terms of pushing incentives and this sort of thing. And so you see that the people who are more in favor of equalizing incomes tend to put a larger weight on the environment and less on economic growth than the others, right? So that's the idea. And if you just look at the simple divide between Democrats and Republicans, so this is something coming from the Pew Research Center 2020, where you see that the Democrats are those who support the environment and the poor and needy, and climate change at the same time. And a more recent one, still the same picture. So this is from last year, where you see something very, very similar. Okay, so given that, why am I talking about a dilemma? Well, because there might be a tension between putting the policy focus on reducing inequalities or putting it on preserving the climate. And actually, you see this tension in economic analysis quite a lot. And what I'll do is to discuss this potential tension. And it's a topic that mixes ethical considerations, but also need a little bit of context about the facts about the cost, potential cost of climate change and the distribution of the cost of mitigation and this sort of thing. And so what I'll do is the following. I'll really dwell first on the discounting debate, and feel free to interrupt me if there is any clarifying questions along the way. Maybe some of that will be very familiar to many of you, but maybe not to all of you. And then I would like to discuss 3 ways out of the dilemma, relating to 3 different considerations: intragenerational inequalities, catastrophes, and co-benefits. So I'm relying on a list of papers done with many co-authors. So it's really a collective work, and especially I was lucky in Princeton to have been involved with the Climate Futures Initiative, where we had many young people coming along, and so we somehow have a nice team that is the legacy of this time in Princeton. Okay, so let me start with the issue of discounting. And I was very happy the other day when I was revisiting some old slides where I had the table coming from the interagency group proposing a social cost of carbon, to see that the group had been disbanded, and I knew that it had been reinstated by President Biden, but they have produced right away last spring a new table that updates the value of the social cost of carbon, where you see that you have different columns corresponding to different values of the discount rate. So for those who are familiar with that, it's pretty obvious, but the idea is try to explain the logic behind what's going on here. And the general pattern is that if you have a high discount rate, you tend to have a lower social cost of carbon, and therefore you would do less in terms of mitigation effort. Okay, so that's the general picture. And so just to illustrate, so tell me if I should jump on that in case everybody knows that, because I guess you are teaching that to many of your students already. But I like to illustrate this, this idea when we look at the problem of mitigation of climate change in terms of an investment, right? So if you take the DICE model of William Nordhaus, and you look at baseline, so business as usual growth rate. So here you have the consumption per capita in thousands of dollars for the world. So it's a world average over 5 centuries. And so you have, it's a bit optimistic perhaps, because we see that the world average income would, consumption actually would really go to staggering levels. But if we made a serious effort at mitigation, and this is something that's totally unrealistic, but in these models, you can really impose that we decarbonate tomorrow morning if you want. And so, this scenario here would have zero emissions, zero net emissions at the end of this decade, which is crazy, but you can do it in the model. And you have amazing benefits from doing that. So much so that you don't even see that there is a cost in the beginning. So let me represent now the net benefits of the difference between the 2 curves. And now, so this is the row curve, no discounting. So we see that actually there is a cost because the curve is below 0 for about almost all of the century until at least 2080 or something like that. And then we have a tremendous benefits, right? So the benefits are so huge that in 4 or 5 centuries, they are way above the current level of consumption per capita. So it's absolutely amazing. Maybe unrealistic to assume so much growth in the future, but that's the picture in this model.
Mark, your baseline is no.
Yes, please.
Sorry, your baseline is no abatement.
The baseline is exactly this is a business as usual. Yeah, absolutely. Yeah. And so the benefits, so Nordhaus is criticized for having a damage function in his models that is considered to be rather optimistic, right? But if you look at that, it looks like really it's pushing the needle in the direction of saying that we would benefit a lot from mitigating climate change. There is no question about that, but we can still, of course, discuss the details of the damage function. But nevertheless, even a sort of optimistic damage function gives us this really amazing picture. Now, suppose I take a very low discount rate. So 1.5, this is in the ballpark of what the Stern report on climate change used as a discount rate, which was a bit outside the usual range. It's a bit outside the range of the table coming from the interagency group. But then you see, so I take exactly the same curve as before, but the red curve now is what happens when I use the discount rate to the future value. So each value is discounted, and the farther it is in the future, the greater the exponent of the term, the discount factor. And so the amazing benefit that we saw almost vanishes and becomes very, very small because of this discounting operation. So this is I think a rather striking illustration of how powerful discounting can be. But this is with a very low discount rate, right? So if I take discount rates which are more like the values used in the table of the interagency with the 3 as the middle thing, even what we have with 1.5 almost disappears. And so if you take 4.5, which is the value favored by Nordhaus himself, then you don't even see the benefits. The benefits almost essentially vanish because they come after the end of the century. So you don't even see them. And so clearly decarbonizing is not such a great policy when you look at it in this way. At least we should decarbonize in a much more progressive and a milder way in the beginning. Okay, so that's the picture. And therefore, it really shows how important the discount rate is. And clearly, if we have a high discount rate, we'll potentially do very little for protecting the environment and the climate. And as you know, the Trump administration was pushing for using a 7% discount rate, which is outside the usual range in our field, but obviously gives the kind of policy that the Trump administration wanted to have. So to explain a little bit the logic behind the computation of the discount rate, so I would like to rely on the approach that says that the discount rate is essentially based on a marginal rate of substitution that's embedded in that's in the social welfare function and trades off the consumption of the present generation versus the consumption of future dates, future generations. And there is a simple formula due to Ramsey, which says that the discount rate is the sum of two things. One is a pure time preference term, and the second is the product of the average growth rate between now and the date that we want to discount, and a coefficient of priority, which can rely on several things. But I will, if I take the view that this is really based on a social welfare function, this coefficient reflects what we usually call in the field inequality aversion, right? And so that gives us, this formula shows that we have two reasons to discount the future. The first reason is that the future is the future, right? So that the pure time preference. And here, of course, it is quite questionable that we should discount the future just because it is not in the present. And Ramsey himself was very much critical, shared the critical view about that, and other famous authors have been very harsh with this idea of pure time preference. William Nordhaus is actually using, in the work that I will show, sometimes there is a discount rate that is just a pure time preference term that is kept from Nordhaus. But Nordhaus motivates that in terms of respecting people's preferences. If people tend to have a bias in favor of the present, maybe we should respect that. This is hard to defend in a context in which we are not talking about investment that people make for their own old days. We are talking about investment we make for future generations. And so the idea that we should put less weight on future generations is much harder to accept than the idea that I'm allowed as a private saver or an investor to put a little less weight on my own future. Right? So these are two different things, and we should probably not mix them. And so I'm sharing actually the view that it is quite questionable to discount the future as such, except for one reason, which is that, and that's a reason that Stern himself endorsed, which is that the future may not exist, right? So if the probability that there will be a future in 2 centuries is less than 1, that justifies the fact that we will give it a weight that reflects the probability that the future is there. And that makes sense, and it's totally impartial, right? There is no bias when you take account of this risk of extinction.
Okay. Marc, can I ask a question?
Absolutely.
I'm just curious your opinion on this. I know this is a deep issue, but how would you respond to the reply to that it's not just personal investment over time, but you're thinking of a government that's allocating scarce resources across diverse social programs, and you want to compare them, in a way that takes account of the opportunity cost of capital over time. So you could build infrastructure instead of having climate policy, or you could invest in early childhood education, et cetera. Does your argument apply in that setting? I'm curious.
Yeah. So the opportunity cost argument is certainly valid in the sense that, of course, we have to take account of the opportunity cost. And so if there is a rate of return that we can get by investing money, we should take account of that. But essentially the idea of computing the discount rate here is to determine the marginal rate of substitution in the social objective. And if the government is able to put the economy and the society on the optimal path, then indeed the social marginal rate of substitution will coincide with the marginal rate of transformation, right? So essentially the market rates will be aligned with that. But it's not clear that we are in such a situation, right? So the current market rates, it's not at all clear that we should use them instead of an ethically determined marginal rate of substitution. So if the two coincide, either it's a pure chance or it's really assuming that we are on an optimal path. And so in a way, I'm not sure I'm clear, but the idea is the marginal rate of substitution is always the right representation of preferences, right, of the objective. And it's not always the case that the opportunity cost as given by the market rate is telling us what the marginal rate of substitution should be, right? So if you are, so it's just as a consumer, right? So if you can exchange oranges and bananas on the market, but if you are not free to choose on the market and you don't have access to the market freely, or you are not optimizing because of some behavioral issues, your marginal rate of substitution may be different from the relative price on the market. And so we are a little bit at the societal level in this kind of situation. And so the true element about your preferences is your marginal rate of substitution, and relying on the relative price may be wrong if you are not optimizing in the marketplace. Right. So so if I hope is it clear enough, Terry?
Yeah, no, I appreciate that. Thank you.
Yeah. And then so let's assume that we accept the fact that extinction may be a factor, but not more. But there is, and that's the bulk of my talk here, the second reason, which is that the future will be richer on average than us. And so if we care less about richer people because we have this coefficient of priority or inequality aversion, then the richer the future and the more we give priority to the worse off, the less we should care about the future in general, and the higher the discount rate, right? And so that's where a tension appears. And this tension has been quite visible in the debate between Stern and Nordhaus. So that's all fluff now, but it's quite clear that they were caught in this kind of dilemma. So Stern obtained a low discount rate. He took a very low pure time preference term, corresponding to this idea that it's only the extinction risk that can justify something like that. The growth rate assumption between the two authors is not very different. But Stern got a low discount rate with a low coefficient of priority. 1 is something that is of course more than 0, but it is considered in analysis of inequalities or social welfare function. It's considered to be more or less in the low range of concern for the worse off. Whereas Nordhaus had 2 reasons to get a higher discount rate. One was a higher pure time preference, and the other was a higher coefficient of priority. Right? So Nordhaus' reasoning was actually starting from the market rate and saying we should reproduce the market rate. And so he introduced, essentially solved the equation in order to obtain the pure time preference endogenously in order to retrieve the market rate. But the coefficient of priority in his approach was based on certain characteristics of people's preferences, especially risk aversion, which can determine the curvature of utility function. But at the end of the day, whether you rely on risk aversion or something else, this entails an inequality aversion in terms of consumption for people. Right? So you have here, so if you are an egalitarian, you would favor the priority coefficient chosen by Nordhaus. But if you are concerned with the environment, you would like to have the discount rate that was proposed by Stern, and the 2 things are very hard to get. Okay, so that's the dilemma for the green liberal. Okay, so this is the key thing, really, these priority coefficients. So that's the context I wanted to start with, and see if we can get out of this dilemma, or if we should put people in front of the choice to make. Either you can be a green person, or you can be a liberal or concerned with social policy, but you can't be both. That would be a sobering message for many of us, I guess. Okay. And so let me discuss 3 ways out of this dilemma. And as I announced, right, so there will be these 3 topics. So let me start with intragenerational inequalities. So here, there is a little bit of internal debate in economics, and I'll show my cards here. So sometimes people say that inequalities between people belonging to the same generation, essentially that's something that has to do not so much with environmental policy, it has to do with social policy. That's another department. And so we should essentially ignore that. And that's the reason why, for some of you who are familiar with this, for instance, in some approaches, especially Nordhaus, actually, there were some precautions taken to avoid putting distributional issues in the picture. And Nordhaus did that by introducing Negishi weights to make sure that the unequal distribution in the world today could be considered optimal, not because it is optimal, but because you wanted to bracket out the distributional issues from the analysis of climate policy. So I disagree with this idea that we should separate the 2 issues. And it seems more rational to say that if what the other department, the distribution department, does is a half-baked job, or is an imperfect job, then we cannot ignore that, right? And so it's a sort of actually classical result in second-best policy, that you cannot really ignore equity considerations when you look at efficiency issues. You have to take into account all the imperfections of the situation. And therefore, climate policy, even if it's not the best instrument to perform redistribution, has to take into account the fact that the distribution may be imperfect. Right? So that's the picture. As is known, right, climate change is likely to actually worsen the distributive issues we have, especially in terms of poverty in the most exposed countries. And there are interesting and difficult issues about climate pricing, carbon taxes, which are likely to be regressive in developed economies and may not be regressive, maybe potentially even progressive in developing economies, but nevertheless would potentially increase poverty there. And so either way, a carbon tax may raise social issues. Okay, so with my team, so I'll start with discussing an old paper briefly, in which we ask the question, what happens if we take the rice model from Nordhaus, which has 12 regions in the world, and if we put inequalities within each region. So then we don't just have inequalities of development between the regions, we also have inequalities between rich and poor in the regions, and some of these regions are some big countries, like the US, for instance. That's one of the regions. And then what we obtain in that paper is that the issue of the distributional impacts of climate change is as important for values that look potentially worth checking empirically. It's as important as the debate about the discount rate. And so in these two graphs where you have the carbon, the optimal carbon tax on the left and the annual emissions on the right, you have the what would be optimal with the social welfare function and the discount rate taken by Stern, which corresponds to a high carbon price and a low level of emissions. So that's the purple curve. You have the parameters taken by Nordhaus, that's the green curve, where you have a lower carbon tax and therefore more emissions. They actually peak toward the middle of the century. But then what we did in that paper was to keep the Nordhaus parameters, right? Whether we like them or not, that's not the issue. We kept them, but we asked the question, what happens if the distribution of climate impacts is not proportional to people's income within the region, right? So we have 5 quintiles within each region. And this Xi parameter that you have that generates the other curves is equal to 1 when you have proportionality, and is equal to 0 when you have a flat distribution. So it's the same absolute amount of damage for all quintiles, and -1 when it is inversely proportional. And the surprising thing about this, simulation is that what we obtain is that, in fact, of course, assuming proportionality of damages to income gives you the Nordhaus results, more or less, because we kept the same social welfare function. But if you consider the possibility that the damages could be flat or even worse, inversely proportional to income, then you go very close to the Stern recommendations, right? Even with the Nordhaus parameter. So this empirical issue of the distribution of climate impact is as important as the discount debate. So that's the first thing.
Marc, do you have any, sorry,
sure.
do you have any work where you're able to ground the Psi parameter empirically at all?
Not really yet, no. And that's another thing we would like to study more. I don't think this elasticity has yet been really estimated as such, but there are several people who are trying to do that. And so, yeah, and if you are aware of work that does that, I'm very much willing to buy it. Yeah, that would be great. Especially what would be super interesting is to check if there is, this parameter may not be the same in different regions of the world, right? So here we had just assumed it was the same parameter everywhere, yeah.
So there's some justification of that assumption from Solomon Xiang's work. Solomon Xiang at Berkeley, and his work shows that poor people in poor regions tend to be disproportionately affected by climate change. But we can talk about that later.
Yeah, right. No, absolutely, yes. And I'm not sure we can retrieve a parameter from that. I remember we discussed that, and we're not really able to do that. But yeah, that would be the thing to do. Okay, now in a follow-up paper, we looked at, can you see the thing okay? Yeah? Okay, good. Okay, there is something strange in the screen. So do you see someone writing on the screen? Yeah, some art. I've never seen that. Okay. Okay, so what we did was to ask the question right away, what happens if we change the if we change the coefficient of priority, can you still see my screen, or is it black now?
It went black.
Okay, yeah, so there's something happening. I hope it's not a hacking thing happening. Okay, now it's coming back. Yeah, I've never seen that. That's quite funny. Okay. All right. And so the question is, if you change the coefficient of priority, right, this coefficient of inequality aversion, what happens? Do you get a greater carbon price or lower carbon price? So the curves here are the carbon price. And what you see is that it really depends on what you don't see anymore, I'm afraid, is the difference between the elasticity of mitigation cost, which we
Sorry,
call omega.
Mark,
Yes.
do you mind resharing your screen? I think it, maybe just unshare and share, I'm sorry.
Yes, yes, let's try that, absolutely, yeah. Yeah. Oh, I see that the person who is doing artistic work is one person in the audience, actually. So
yeah, I
maybe...
think I had it set for multiple sharing, the multiple setting, and I think accidentally someone's interacting with it or something.
Right. Yes, that makes sense. Okay, so let me try again.
Great, thank you. Now
it's
we can
okay.
Yeah.
Okay, good. Yeah. And so what you see here is that. So let me explain the colors, right? So you have the value of this parameter, so it's called eta here, and it is, yeah, again, okay, sorry about that. I'm not sure I can do anything about it on my end. Can you ask perhaps this person to stop sharing the screen?
Well, I think it's one participant can share at a time in your sharing, so I don't think that's the issue now. That seems to be something else.
Ah, okay.
I'm sorry.
No, that's fine. Let me do it again. Okay, good. So, yeah, let me try. Okay, yeah. So, and so what you get here is that when the yellow curve is higher than the black curve, that's the situation where you have a higher carbon tax when you have a greater inequality aversion, a greater priority for the worse off. And that's what you have on the right-hand side of these graphs. And so essentially what determines the fact that you have that is the difference between omega, the elasticity of mitigation cost, and psi, the elasticity of carbon climate change impact. Yeah, I'm afraid I have to stop again, but
I have no idea. I'm sorry.
Right. Yeah. No, I'm sorry myself, but I've never seen anything like that. Okay. And so what happens is that you'll have more climate policy when you get higher coefficient of priority, when the rich people tend to pay more of the costs, when omega is more than 1, which corresponds to essentially the cost, mitigation cost is more than proportional to people's income, okay? And when climate impacts are disproportionately falling on the poor, right? And so you want to protect the poor and you make the rich pay for that. And that's really what makes the high coefficient of inequality. I'm sorry, I think it's Lee Nover who is playing with the thing. So, but that's okay, that's fun. And looks like it's a child who is playing. So that's very nice.
Is there?
And so that's the general.
I don't know. Sorry.
Yeah, go ahead, Terry. Yeah, so you see.
Let me try.
That's quite fun, actually. But it's and so that's the picture. And so but one thing that you might notice is a common, if you see the numbers well, one parameter that is the same everywhere is the raw parameter, and that's the pure time preference, which is 2 here. And 2 is a pretty high level, so it's the high range of the values taken by Nordhaus himself. And so what happens is that we observe this phenomenon of being able to obtain a tougher climate policy if we have a higher priority for the worse off. We observe that only when we have a substantial pure time preference analysis. And that might look strange, but what happens is that with this model, if you have no time preference and no inequality aversion, you are back into a situation which looks very much like what I showed in the very beginning. Essentially, you are looking at the total income over all generations at the same time, because there is no time preference and no inequality aversion. So it's essentially it's total income over the whole world and over all generations. And that's maximized if you decarbonize very quickly, right? And so in that case, you have essentially no leeway to decarbonize even more if you increase inequality aversion, because you decarbonize immediately already in this setting, right? So that's the sort of situation you are in, and I hope I'm clear, right? But essentially, it's if you have no pure time preference, you will never be able to obtain this situation where you do more climate mitigation when you have a greater priority for the worse off. That's the situation. Okay, and so
Marc,
I should
I'm
do
sorry.
it again. Yeah,
this,
I see.
This is Simon. Just want to ask you about the backstop
Okay.
technology. Probably you haven't described that yet. Thank you.
Sorry, I couldn't hear very well. What was the question about the technology?
Yeah, the backstop technology.
Yeah.
I mean, oh my goodness, who is that? So
You want to die tonight?
Okay, sorry, I'm going to remove this person.
I'm an emo.
Okay.
Okay, I removed 3 people. Now, hopefully, we're.
Oh my
we're in
goodness.
sorry, can you share the screen again? I'm sorry.
Yeah, right. So the backstop, yes. Okay, yeah. It's nice. I've been teaching for 2 years with Zoom. I never had anything like that. That's really fun.
We've never had this either. It's interesting.
Yeah.
Yeah, so you see the backstop here, which is
Right,
this declining curve, right, Simon?
Yes, that's correct. Yeah.
Yeah, and so we just took the backstop assumption from Nordhaus in rice.
Okay, so that's from using rice, not the nice models, right? Just to make
No,
sure.
yeah, exactly.
Okay.
So
yeah.
the nice model, nice means nested inequalities and
Right,
climate economy, but it's essentially rice with quintiles inside the regions of rice.
Okay. Okay.
Yeah. But the rest, the damage function and so on, everything remained the same, but with these additional parameters for the distribution of climate impacts between the quintiles and the distribution of mitigation costs between the quintiles. So we could disentangle these various things, but with assumptions. So the distribution of mitigation costs, that's more or less a policy variable, but the elasticity of climate change impacts, that's an empirical question.
Okay, thanks.
Actually, it's not just an empirical question, I should say. It's also partly a policy issue, right? Because you can have adaptation policy that shields the most vulnerable people from climate impacts, and then you would have something that reduces that increases this elasticity, right? So that protects the people. But we don't have, in the model, we don't have the cost of such a policy, right? So it's not something that is explicitly represented.
Okay, thank you.
Yeah. Actually, I'll talk about something that partly introduces such a policy later on. By the way, you should tell me when I should stop, because I'm not sure I can check the clock.
Yeah, you're okay. Another 15 minutes is good.
Okay, good. Let me try to check that. Okay, good. And so another thing that I wanted to mention coming from a more recent paper is that this issue of protecting, of checking the distribution at the national level can be quite central for the discussion of the optimal carbon price. And in that paper, we took the following story. Suppose you have a global social welfare function, which may have its priority coefficient. Suppose, for instance, you have a high priority coefficient or low, it doesn't matter. You have certain values embodied by this social welfare function. Now, imagine that actually inequalities within the countries or regions of NICE are controlled by local authorities and may not maximize this social welfare function. For instance, you may have some governments are less egalitarian than your global function or more egalitarian, but they don't implement the optimal distribution within their jurisdiction, right? And so what happens then is that, in fact, it doesn't matter too much if for the climate, for the determination of the optimal carbon tax, it doesn't matter if their distribution is not optimal, provided that they protect that distribution. And protecting that distribution means that when the distribution would be changed by the the climate impacts, they react and they restore the distribution that they want to have. So essentially, do they have some kind of insurance against climate impacts in place locally, or do they not have anything like that? And so what you have in this graph, so maybe you could look at the curves on the top, because here we distinguish different carbon taxes for different regions of the world. But so the ones at the top are the US curves. And can you see my my mouse if I do that? Yeah.
Yeah, we can.
Okay,
yeah,
good. Yeah. And so you see, this curve here is the curve that you would have if the distribution in the country was perfect equality. So there would be no issue of inequality in the US in that case, right? And now, if you assume that actually the current distribution is maintained, but is maintained even when you have climate impacts, right? So in that case, what you obtain is the curve that is the dashed curve, which is just below it. So essentially, there is almost no impact on the carbon tax, provided what matters is really that there is an insurance against climate impact, so that the distribution is not disturbed. But whether you have inequality or no inequality, that's not really the issue. Where you have an issue is when the government at the local level does nothing to preserve the level of inequality it wants to have. And that's what you get when you have this higher carbon tax here. So that's when you use the global carbon tax in order to provide some insurance through lower climate change to the people, because their local jurisdiction is not protecting them against climate impacts. Right? And so you would have a worse inequality coming from the climate impacts itself. Right? So the lesson here is, it doesn't matter if inequality is not optimal at the local level. What is really important for climate policy is the fact that there is some insurance provided to protect the distribution, so that the distribution is not worsened by climate itself. And this is quite natural, right? Because the climate policy is just affecting the climate outcomes, and therefore you have a lever that affects these outcomes. And if these outcomes don't really change the distribution, because the government has some insurance system, then your lever is not useful for that. And you don't need to take into account these inequality problems at the local level. Terry, you wanted to say something?
Well, oh yeah, sorry. No, I just didn't really. So is the difference between the black line and the higher SCC curve just the difference between having Negishi weights and not effectively? Or you're explicitly modeling these transfers here? Or
yeah, we don't have Negishi weights here. What happens is the difference with so the two curves, this curve, the top curve here is the case in which the government does nothing. And so when climate change happens and worsens inequality in the country, there is nothing happening at the local level. And so if the poor people suffer more from that, and so the assumption here in terms of climate damages was that it was a flat distribution. So the Xi parameter was 0. Okay. And so the poor were receiving the same cost as the rich in absolute amount, which is in proportion to their income, of course, is much more. And so the distribution is worse by climate. So you have an instrument which is climate policy. You can use it in order to avoid worsening the distribution. That's what you do here. If the government has the protection of the distribution by other policies, and that's that's the dashed curve that is below here. So that's what we call nationally optimal transfers, right? So they might not be optimal for the global social welfare function, but they are somehow optimal for the US government. Then it's okay. We don't need to use climate policy to take care of that. Does it make sense? Yeah. Okay. So let me say a few words about catastrophe. So I'm sure many of you are familiar with Weizmann-Dismor's theorem, and this is, I mean, oversimplifying. This is all about the fact that a catastrophe may generate a situation where there is a marginal utility in the future that is unbounded. Right? It may not be infinite, but it can be arbitrarily high. And when that's the case, it's very hard to scale your effort now. And so it's a sort of breakdown of cost-benefit analysis. And clearly, if you bring the question of the priority for the worse off in the picture, if the catastrophe corresponds to poverty and this marginal utility going to a high level, if you have a social welfare function with a priority for the worse off, it's likely to increase this level of marginal utility in terms of the social priority, right? The social marginal value of the potential recipient of beneficiaries of your policy will increase. And so you should care more about catastrophe. Right? So there is a natural argument here that if there is a risk of catastrophic consequences due to climate, if you care more about the worse off, obviously you should care more about this catastrophe. We have an old paper with Stéphane Zuber where we looked at the introduction for the computation of the discount rate according to the Ramsey formula, but in a situation in which you may have risk and uncertain and inequality within generations, right? So you have not just a growth path, but also several possible levels of growth and consumption in the future. And you may have inequalities within each date in the future. And so in that case, what happens is that really what drives your discount rate for the long-term impact is the worst scenario for the worse off. And so any potential catastrophe, even if it has a low probability, will drive the discount rate in the far future. Of course, the speed at which you converge to this low value depends on the probability of this catastrophe. So if it's very low, you will converge very slowly. But nevertheless, you have something like that. And now we are working on a draft of a paper where we extend that to moral uncertainty. So if you're not sure about what the right social welfare function is, then actually the moral theory which produces the lowest discount rate will determine the limit value of the discount rate when you take a sort of aggregate view over all moral theories that look credible to you. And so essentially, yeah, it's the lesson would be something like the moral theory that gives you the lowest discount rate is driving the thing and will be itself driven by the worst scenario for the worst. So that's so essentially the lowest discount rate is always winning in the long run, whatever the reason for hesitating about discount rate. And we have done some more recent work with Aurélie Méjean and Antonin Potier about extinction risk. And we have introduced so this is not exactly, let me just show that. Optimization, we just compare three possible policies: business as usual, a 3 degrees Celsius increase in temperature or 2 degrees Celsius increase. And we look at what happens when we adopt different attitudes to population size. So you can either look at total utility, right? So you add up the utility over all generations, or average utility. So then you don't really care about the number of people. So clearly, if you compare the top and bottom tables, clearly when you care about the size of the population, you care more about preventing extinction. And therefore, you will favor a more ambitious policy. So what we have here is a parameter that says if you increase temperature by 1 degree, this will increase the probability of extinction by a certain number. And the numbers are on the right of these, so that's the B coefficient on the right of these tables. They are very small for certain values, but they go to values which are close to the values similar to the values of Stern and even higher than that. And what I wanted to highlight is not so much the fact that we have obviously a greater concern for extinction when we care about the size of the population. So the total utility approach is more ambitious for climate policy, but also there is something strange happening. So the columns of these tables correspond to degrees of priority for the worse off, from very low value 0.5 to 5. And you see something happening in this third row here, which is that you will favor an ambitious policy, 2 degrees Celsius, with low values of inequality aversion, for the reason essentially I gave earlier. But also if you have high levels, right? So there is a sort of a reversal of preference here. And the reason is a bit strange, and I'm not sure it's something very deep, but it has to do with the fact that when you have a high inequality aversion, you have a greater curvature of your utility. And so when you have growth, the benefit of having more people in the future is somehow getting flatter. And so you care more about this in the future. And so it's not so much growth, but it's just the existence of the future that becomes more important. And so we are not fully sure we fully understand actually why we have that, but it's a sort of calibration effect of the parameter itself on the utility level that matters when you have a potential change in the size of the population. So that's another case in which actually you could want a more ambitious policy if you have greater inequality aversion. Maybe I should hurry up a little bit and briefly mention co-benefits, which are a different topic that also can push in the direction of saying that actually, if you care about social issues, you should care about the environment as well, or you can care about the environment as well. So we have two sets of works, one about health co-benefits, and here I'll go perhaps quickly. So you can, if you decarbonize, you reduce air pollution. And it's a bit complex because a cleaner air is actually potentially triggering a higher temperature. But the thing is that you can really obtain a lot of benefits, and these benefits are very high in emerging economies. And so China, India, and including sub-Saharan Africa stand to benefit a lot from such policies. And so this kind of graph is just looking at the evolution. So the black curve is showing the level of consumption. So in the standard analysis with no health co-benefits, you have the typical curve where you have a sacrifice in the beginning and then you benefit in the future in terms of consumption. If you introduce and you monetize health benefits, health co-benefits, actually there is no sacrifice whatsoever. The health co-benefits are so high that in terms of monetized value of comprehensive consumption, you are always above zero. So pretty good for emerging economies and overall pretty good as well. So that's the general picture. Maybe I should jump now to the issue of social co-benefits. So the idea is you can recycle carbon tax, and in particular, you can do what the Climate Leadership Council is advocating in the US, redistribute an equal check, the tax revenue as an equal check to all people in the country. And we've done that with a nice model. So uniform lump sum transfer redistributed to all quintiles, and see what we get in terms of social consequences. And so in this graph, you see that the bottom quintile is actually benefiting. So on the left-hand side, you have what happens if there is no recycling. And on the right-hand side, you have this recycling policy. And there you see that actually the bottom quintile is benefiting for quite some time. At some point, it's falling a little bit below zero. Why that? Well, because once we have almost fully decarbonized, and especially when we have fully decarbonized, there is no carbon tax revenue anymore. And so there is nothing to redistribute. And then there may still be a little bit of mitigation cost. And so that's a situation when the poor can actually no longer benefit because recycling has exhausted its potential. But nevertheless, this happens pretty far in the future at a point where the bottom quintile is not so poor as currently, right? So the situation is not as dire in terms of social impact. At the bottom, you have something which is about the Gini index, similar story. The Gini will be decreased by this very substantially by this recycling. Let me perhaps, yes.
Marc, sorry, this is Ed. If you could go back, I just had one question about this, so I didn't want you to leave it. Is that it appears that that's not all your regions do you have these benefits from recycling. So for example, it looks like it's the European Union, the black one, where there isn't such a gain from recycling. Can you explain why you're observing that?
Yeah, here, right? So that's in terms of Gini.
Yeah, and also above in terms of changing consumption, they don't have. There's not much change for them.
Yeah, it is positive though, right?
Yes.
Why is it a little bit lower in terms of percentage? Maybe because the inequality is already lower there.
Is that true in France? And that I thought Piketty, for example, was saying, that France has got one of the worst inequality problems.
No, actually, I mean, yeah, the situation is not improving, but the Gini is not as bad in the EU as it is in the rest of the world.
Okay, so it's where you start out.
Yeah.
And this is after tax Gini.
The whole of the EU, yeah.
And this is, excuse me, this is after tax Gini.
Yeah.
It's a more progressive taxation.
Yeah. So the Gini is in Scandinavia, it's below 0.3, right? It's closer to 0.2, so that's pretty low. For the European Union as a whole, I don't remember what we have in the data.
Sure.
It's probably the most, the least unequal region of the whole model. Yeah, actually, we should see that in the Gini here, but we don't see much, unfortunately. No, this is still a change. No, we don't. So we don't have the levels here. Sorry about that. These are just changes. Yeah. Okay, but I should conclude. So let me just finish with this last slide, where we ask the question: what happens in terms of optimal policy when we do this recycling? Is the optimal policy changed or not? And actually, it is changed quite substantially. And so we move. We can look at the left-hand side here. So the red curve is the carbon price in the standard no recycling scenario. The blue one is the thing when we do the recycling. And what happens is that because we have this social co-benefit, we should do a lot more of carbon mitigation now, because that would increase the carbon tax and increase the recycling. So we have this benefit that justifies doing much more now. Even to the point where it's not really realistic, right? 60% decarbonization right away, that's impossible. But in the model, it is possible. But then we want to keep recycling for as long as possible, because this benefit is something that we want to keep. And therefore, we will actually fully decarbonize a little later. Sorry, I was wrong here. I said this was the carbon price. No, this is the decarbonization rate. but it looks very much like the carbon price. And so what we should do is actually decarbonize later in time, because it is good to have this social benefit for a longer period, right? And so in terms of, it's quite nice in terms of impact on the temperature. The temperature would actually rise to the same level, but reach its peak later in time, which may have other co-benefits, for instance, for biodiversity and this sort of thing. But so we don't have that in the model, but that's the story. And so thanks a lot for your attention. Let me just close with this summarizing slide, but I don't need to rehash the main story. Thanks a lot.
Thank you very much, Marc. Open to questions. I have a question but someone else is welcome to speak up if they're ready with one. I guess I really like the exploration of results when you remove Negishi weights and you have these inequality effects. I don't quite know what to make of. There's a kind of uneasiness. I think the same reason that, say, Nordhaus was led to introduce Negishi weights to not confound the impetus for climate policy with the desire to remove existing inequalities, say. And I think actually your slide, one of the papers you presented where you had these redistributive policies might have spoken to my unease and question, although I didn't really understand what was going on there. But I guess I'm curious if is there like a conceptually coherent way to disentangle the desire to have higher marginal utility in poor Africa, say, or the lower income groups in Africa, if we have climate policy that disadvantages or further hurts those people and increases inequality, you'd like to not just remove the fact that they have a much higher marginal utility. You'd like that the magnitude of their marginal utility to matter, which it doesn't with Negishi weights, because you effectively obliterate that, I think. But to not allow, it's like disentangle the ethical or moral impetus to do more because of that, but without allowing it to undo existing inequalities. It's a vague thought. I have an unease with simply opening the floodgates to removing existing inequalities and not knowing what portion of the resulting suggestion for climate policy is due to just opening the existing floodgates that aren't currently removed versus a moral impetus to protect the future or to avoid increasing inequality in this action that has long-run repercussions.
Right. Yeah. I think that the general idea is pretty simple. You can't ignore the background situation for any instrument, right? And so it's impossible to separate topics and associate instruments to when you are in the second best setting, associate instruments to particular objectives. But you're right. The thing here is actually that what matters, what you should care about, and you're right, you should care about both the level of ambition in terms of mitigation and the distribution of the cost of the policy, right? And so the distribution of the cost of the policy, that's obviously a social issue. That's pretty clear. And I think we agree on that. Now, as far as climate impacts are concerned, I think that indeed that paper that we did on national policies sheds light on the issue. So essentially, it's not as if the level of inequality, the status quo in various regions of the world was mattering as such, right? In fact, it does not matter very much. It affects a little bit, but it's really in the thickness of the curve, the optimal policy. The only thing that matters for determining the social cost of carbon is the impact of climate itself on the distribution, right? And insofar as at the local level, some insurance against climate impact is protecting the distribution, even if it's a bad distribution. That's not the point. Right? Even if it's a bad distribution, that's okay. insofar as the distribution will not be affected by climate, then climate policy need not take care of that. I mean, the social cost of carbon is not affected by that. But of course, the distribution of mitigation costs remains an issue. Does that make sense to you? You see the idea, right?
Yeah, what paper is that?
So that was the paper where we had the US curve where
What's the title? And I'm not familiar with the paper, so.
I don't remember the title either. So it's in the slide where I gave the references. It's let me go back to it. That's the social cost of carbon and inequality. That was in GIM last year.
Okay.
Yeah.
So
the subtitle is when local redistribution shapes global carbon prices. But in a way, the message is if local redistribution takes care of the distribution, whatever way, it does not shape global carbon prices, right? So in fact, it may shield distributional problems.
So is it then true that if you have local redistribution, then removing Negishi weights has no effect?
I mean, there are two issues here about Negishi weights, right? So I think Nordhaus introduced Negishi weights initially because he had a model where the instruments were the growth paths of regions themselves. And so he wanted to avoid equalizing consumption all over the world, which would be unrealistic, right? We will never do that immediately. It's totally impossible politically. And so there was this, but it was also doing something else, which was to somehow bracket out distributive issues from the climate policy itself. And the risk with Negishi weights is if you really make them endogenous. So I'm not so familiar with the details, but you may have problems of time consistency. So Francis Denig and a co-author has made a paper on that, showing that you may have time consistency problems when you do that. But essentially, what we have in our own modeling is we have no transfers across regions of the world. And so the problem of equalizing consumption cannot occur, right? So we remove Negishi weights, but we impose constraints. So there cannot be equalization of consumption anyway. So that first function of the Negishi weights is no longer needed in a way. But the second function, I think, was problematic. We do want to take account of what happens to inequality, and in a way that that really takes account of the impact of climate on the distribution, right? So if it has an impact on the distribution, that's a concern about climate, and it's a concern that is relevant for climate policy itself.
If I may come in, I've always taken a slightly different view on this approach, which goes back to some of your earlier graphs of the assumptions about what happens with consumption per capita over time and the business as usual. The way these models work, and the Dice, Rice, and now your NICE models, you know, they say here's business as usual. This is what will happen if we carry on doing what we do. This is what will happen if we impose some kind of climate policy. But the real world, the business as usual world, is a world of distorted markets. And the most distorted market is the energy market. And in there, what we have is a totally unlevel playing field between fossil fuels and other sources of energy that would be part of the thing that would come in and lead to decarbonization. The result is this, is that I actually think the business as usual projection is incorrect to start with, because that distortion is unsustainable in energy markets. And all you need to do is look at, so unsustainable, both in terms of possibly in terms of the economy itself, because it's becoming less productive, the economy over time, but also certainly in terms of social welfare over time. And you have to look no farther than the IMF's International Monetary Fund studies of the impact of the underpricing of fossil fuels, people by Ian Perry and colleagues, where they actually calculate what's the fossil fuel subsidies, the what we consider subsidies to start with, and what their impacts, and then the ex post impacts of the studies of the underpricing in terms of climate change damages, loss of health and human morbidity from air pollution, congestion costs, all the things that are the bad things that happen. And so that is not sustainable. And so when I see the business as usual always going up exponentially, and we're interested in the gap, it worries me a lot that we are actually overestimating the underlying BAU ability to deliver if we're thinking about it in welfare terms over time. It's totally unsustainable, what the path we're on right now. And of course, nothing is more clear of that than the growing risk of catastrophe from this distortion, which is happening not just with climate change, but with all sorts of other global environmental risks, from water scarcity to marine to obviously biodiversity and land use change. So that's always been my concern.
Mm-hmm. Do you have a similar concern? That's very interesting. I was not aware that we could frame. So of course, in putting aside the climate impacts themselves, that just the inefficiency of the energy sector due to this bad pricing situation was a big break on the growth itself, right? That was not obvious to me, so that's interesting to hear.
It's very possibly going to be a break on growth, but it's certainly going to be a break on welfare ultimately.
Oh, right. Yeah.
Sure. And certainly
yeah.
distribution over time will be worse under.
Yeah.
Also, I'll send you a paper that was published in Gene last year, that there's so many other risks that are coming on that are compounding. So for example, this paper was on land use change in tropical regions, and it's increasing the risk of another disease outbreak of the type we just saw, and or another one that more like Ebola or something. And so this is again business as usual, leading to these compounding of risks and uncertainty.
Right. And then that suggests that the benefits from mitigation are much bigger than what we say, right? Yeah, that's very interesting. Are you? I'd like to hear your opinion about the realistic growth rate under an aggressive mitigation policy. Are they nevertheless still unrealistic, even if we do protect the environment?
I have a hard time projecting 50 years, much less 500 years in the future. So, but certainly I'm very concerned that it's not a smooth curve that we're seeing, and we're going to see, I mean, and just look at the past 20 years. We've had the Great Recession, we've had this pandemic, we've had periods, and just in the last 2 years, the degree in which inequality has increased in the world and poverty. We're talking, the World Bank estimates say from 2020-21, we may have thrown 150 million minimum, maybe 250 to 300 million people back into extreme poverty.
That's right. Yeah.
You know, that these are discontinuities that we're going to see more of, and certainly any catastrophe, whether it's going to be a disease like this one, or it's going to be a major environmental event, is going to have similar effects. And again, these models assume continuities, which are not clear. And so that's going to be the future. And that's what worries me over the next 20 or 30 years. And just taking one, for example, what's now routine on the Gulf Coast of the United States, for people to say, well, let's forget about talking about once in a 100-year event. That model doesn't hold anymore. Things like the Hurricane Harvey in Houston and Katrina in New Orleans, those are going to be the norm coming every 5 or 10 years.
Right.
Yeah.
Mm-hmm. So in the paper about extinction, we had some trouble sometimes with people reacting to the idea that extinction was in the cards, but there is something close to extinction that we tested, which is going back to a very low level of well-being in the future after some big event, right? And I'm not so worried, I should say, about physical or geophysical tipping points as much as socio-political tipping points. I'm afraid these are the most dangerous ones.
Exactly.
So in that paper, is extinction just modeled as you no longer have future utility?
Yeah, right. So we did that, and I don't remember if it's in the paper or in a follow-up paper where we did instead of having a complete disappearance of humanity, right, where you stop, there is no longer anybody after some day. There is a variant where we keep a low population with a low level of consumption for a very long time. So a sort of dystopian future where people
I guess
can't
that
really
makes
recover.
that's more coherent, right? Because your utility function is often a negative number, for example, or it's the
Oh
the
no,
magnitude.
what happens is yeah. So the utility is zero when you don't exist, and it's positive if your consumption is above a certain threshold, as
Okay.
is often done
Okay,
in,
so
in health. You see in health economics, if you fall below, if you fall in really below the sort of extreme poverty threshold, your utility is negative. So you better not exist. All right. So in that case, so that's a bit extreme, but that's the kind of modeling we do.
In the models that I have, where I have a bad event like an ecological collapse occurring, utility doesn't go to zero, but it's a different state where you have a lower level of utility. Right. It's constant. So it's a very, I think, nice way of doing it. It's still very scary.
yeah. But the extinction is just, it's as if everybody was at zero forever, right? So
yeah, I don't buy that completely, but
right, yeah.
Yeah, well, the only other thought I had was related to the empirical your psi parameter, the distribution of damages across income groups. It seems like, so is it true if psi is -1, then the dollar cost of damages is higher on poor people than on rich people?
Yeah, exactly. Yeah. So it's actually pretty dire. Yeah.
I guess that's because you can imagine a rich person owns stock in companies and owns a company or owns, so they benefit from a lot more of the infrastructure of the country. So there's kind of like a scale effect of all the things that might potentially.
Exactly. So that pushes in the other direction. Absolutely. But this includes, I mean, this in this model, consumption includes health issues as well, right? So if you have serious health problems, that can really diminish. So that can be a high cost. But still, you're right. If it hits capital, well, of course, the owners of capital are more affected than the others.
Great. Well, thank you. This is a far or a broad, super fascinating, fun, discursive discussion of lots and lots of topics. And I really appreciated it. Thank you so much.
And I apologize to Greg. I see he just posted something on the chat. Have you seen that? Maybe I should say something about that.
Yes, please.
Depreciation of capital get progressively more extreme. So the idea would be along the lines of Ed's story, right? That capital would get destroyed more often because of extreme weather events or this sort of thing. That would be the idea. So I guess, we could imagine doing that, certainly. That would make sense, I think. Yeah. But this is not done currently.
No, I didn't read all the messages, but it looks like a number of people said thank you.
Yeah.
No, thanks a lot. Thank you.
Thank you, Marc.
Really appreciate it. Take care.
Thank you.
Bye.
Thanks, everyone.